Linux defense in general and how we would go about that. We have UB coming up. We have some more competitions for us coming up in the spring. We have some people in CDT. So if you're in any of these things or you just want to learn like how to defend Linux a little bit more, this is a great resource to get going on that. So kind of an overview. The things we were trying to focus on throughout this is just hardening the system. We're just trying to lock it down a little bit more, and we're trying to, monitor what's going on. We want to know what the system's doing at all times, and we don't want anything to be running on the system that we're not in control of. One of the most important things, and I've even bolded it on here, and we're going to go over it later, is read your logs. This applies to not even just Linux. This applies to Windows. This applies to everything. Read your logs. They tell you what's going on in your system. They're there for a reason. All right, so how code runs. Linux has a lot of just random things. It's like, yeah, let me execute these functions for you. And you can just stick things in there, and it'll run them for you. So some of this is services. You can make malicious services. You can have them just restart every time they're killed. That's fun for blue team, because you look at a process, you're like, this looks really bad. You kill it, and then like 10 seconds later, it's like there again. Like, how did it happen? Systemd or service managers. Cron tab's another fun one. It's literally made to run commands at certain times. So that's great for people who want to run bad commands on your system. You just stick in some commands, and it'll run every minute, every year, every day, whatever you want. Binary shimming, this is fun. You can just stick a bash script instead of a file, like ls, for example. You have the ls command, you stick a bash script in there, and every time you think you're looking at your files, you're also calling back doors. Prompt command, this is an environment variable you can set in bash. That just runs a command every single time your prompt is displayed. So when you hit enter, it runs a command. So like flushing your firewalls in there, that's a kind of a fun one. There's just a lot of things, and there's too many just to put on one slide. These are just everywhere. So you just kind of have to get familiar with the system and figure out how to stop the root problem of these, which is like, how do we stop execution of commands? How do we stop the commands, even if they are executing, from beaconing out, from reaching the servers? But again, there's just so many different things you can do. This is just like a very, very narrow scope of how things can run on the system. So services, we kind of mentioned them. Services are just a fancy wrapper for starting processes. So we want code to run. We want code to run consistently. We want it to run and produce all the output. We want to know what it's doing. That's what the service manager does. It just takes a process and it makes it better. So we can run completely without the user's interaction, so you never even have to log into the box. You don't need like a TTY or anything in order to have these running. So there's two kind of major ones you're going to find on Linux distributions. Almost all of them now are on Systemd. Some of the older ones and some of the more hipster ones are on sysvinit, which is just a bunch of bash scripts. But so those are the kind of two you really need to worry about. And then if you get on like weird Unix systems, they have really weird ones. But for the most part, like Systemd is what you're going to find on like Ubuntu, CentOS, Debian, all of that. Okay, so the code on the system, or the code on the service manager starts and stops other processes, which means you can have a service running, as far as the services manager is concerned, without having an actual process mapped to that service. So, and you're thinking that like that's weird. How can a service be running if there's no actual process running for it? But that's because your system manager or your system process manager is also running. So for example, you can have it on a loop. So you can be like, I want you to sleep for 40 seconds and then run this service again. So the service is still running. It's in that loop phase, but there's no actual process that is sitting there sleeping. It's just the service manager will start it. So that's something to be aware of, is like in PS, you won't have some of your processes being shown, but that doesn't mean there's not a service that's running associated with it. So this is something that's really important to monitor, especially like if red team's in there messing around, because services, you can have them sleeping, you can have auto restart. There's some weird stuff with Systemd where it can like open a port, and then as soon as you connect to it, then it will start the process for the service to connect to. So like there's a lot of weird things. Most of the time that's not the case. If you have like SSH or Nginx, it will be a process running, but not all the time. So just be careful of that, because you can have services running that are not mapped to a process if you like look at the process output. It maps it, especially it does binary logs, and you can view those with journalctl. So like journalctl-e just takes you to the end of the log file and you can start reading. But this is really good because almost every core element of the system, even like cron, DHCP, your networking stuff, all the things that like you think about on a Linux system are pretty much baked in or implemented through systemd. So you can look at all this and you can see what's happening like at all times. If your SSH keeps crashing or your web server keeps doing something, it's probably in the journal log. This is the most important log on a file or on an operating system for Linux. So any like thing that's happening on your system, it's probably in the journal CTL log. And there's a lot more things you can do. You can search it. There's a bunch of command line flags, but just kind of look that up. Use man, Google to find all that. But yeah, so this is probably the most important log file you can find. Next up, users and groups. This is kind of like a very common one. You just want to know who's able to log into your system. So you have the 3 files. I think we covered all this in the Linux basics. So like, if you want to reference some of the more in-depth about this, just go check these out. So passWE stores user information, shadow stores the password hashes, and group stores group information. You want to go in, just make sure like users aren't part of the sudoers group or part of the wheel group where they can get administrator on the system. You want to make sure that users that are like potentially malicious or users that you don't know about can't log in. For sudo, you want to make sure users who aren't supposed to be able to sudo can't sudo. One of our favorite things to do as red team is just put like all, no password, all, which basically means any user can just say sudo and they don't even have to type in a password. You use sudo and you get root immediately. So that's something to look for, and you can use vi sudo to edit that. And then there's a bunch of commands for like working with these. And again, this is like, if you look at like any intro to Linux, I think even in our intro to Linux, we covered some of these commands. But just going over it real quickly, vim etc password, look at those. You can lock an account so they can no longer log into the account. It puts something in the password hash so that when they go to sign in, it'll just like lock them out so they can't even SSH in. You could also change their shell to bin false. If you change their shell to bin false, as soon as they log in, it's going to run bin false, which is like basically a no-op binary, and then it'll just immediately log them out. So that's another great way to stop them from logging into the system. One of the things you want to do in competitions too is disable users, don't delete them. You're going to want to be able to go back, and even in the real world, you're going to want to be able to go back and show, hey, this is what I found in the box. You don't just be like, yeah, there was this bad user and I got rid of it. Okay, what was the username? I don't remember. Who put it in there? I don't remember. I deleted it all. But like, don't delete things. Just go in and comment them out. Put in like things to make them break instead of just deleting them out of the system completely. Configuration files. Linux is like notorious for just having everything sitting around in a text file that can just control its entire behavior. Even things that like you really don't think should be in a text file that can control the entire system's behavior. So like common system configuration files, you have your bashrc, etc profile, and bash.bashrc. Who can tell me what those do real quick? Anyone just want to, what's the bashrc do? Don't make me call someone out. Shannon, what's the bashrc do? Jim, what's the bashrc do? It runs a script when you run bash. So you can put things in there. So check your bashrcs. Man, the interaction here is kind of sad today. Okay, etc environment. That is the environment variables that get loaded into all your shells and maybe all your processes. I'm not sure. So we just talked about that prompt command. It runs a command. It runs a program every time I run a command. You could load that in there. So then anytime anyone logs into the system and they run a command, it will also run my command. Etc sudoers, we just kind of talked about that. That configures who can sudo. We have not so common files. You have input RC. That controls how the C read line function operates. So you can be like, yes, I don't want you to read the letter E. So whenever you type E, nothing will happen, right? Or you can make it do fun things where like every time I type vim, change it to nano. Or just anything, really. You can just control anything the C read line library uses. So it's just a system configuration. You're kind of like, why does this exist? There is a reason for like back in the day, but just things to be aware of. etc pam.d. This controls how all of your authentication works. Within one line, you can change one line in this file and make it so passwords are irrelevant on the system. Every time you go to enter a password, you just press enter and it'll just log you in. So like these are configuration files that are very important to the system. Kind of research them, learn about them. Especially if you're going to do on a blue team in a competition, because red teams love to take advantage of all this stuff. Okay, hardening SSH. Every service, like the system has its configuration files. Every service also has its own configuration files. SSH is probably the most common service, even if you're not like security, CS students, you're learning SSH for some of your classes. SSH is like, it's how you get into a system to control a Linux box remotely, is the most important thing, because SSH fundamentally is made to give out shells to people. So if you can somehow have a misconfiguration in that, then it will just give out shells, complete access of your system to anyone who doesn't necessarily need to have it. So that's one of the most important things for us to lock down. One of the cool things you can do in this, and not a lot of people know this, is they spend so much time trying to like delete users and making sure the users aren't in etc passwd. But what they don't realize is you can just tell SSH, be like, hey, only let this user in. So in this case, only user 1 would be able to log in, or user 1 and user 2. So anything in the allow users, only they can log in. It doesn't matter if it's a valid user with a valid password. If they're not in there, they cannot log in through SSH. So that's just another measure to keep people out of the system. What else you can do with that is you can lock it to a single IP address or a subnet. So if you know, hey, everyone on my team is coming from this subnet, this 192.168, you can lock that in. So then only those users who are coming from that IP address can log into the system. This is super critical because a lot of the times you can have everything else locked down, but they might have like just one user account that just keeps popping up and you haven't locked it out. But in this case, even if they know your credentials, they know your username, and they have complete access to your system, like can hit SSH through your firewall, they still can't log in if you've configured it properly. So it's all about like the concept of defense in depth, like layering different elements of security. Permit root login, no. Just like have a user that you say, this is me, I can sudo, and that's it. No one else should be able to log in. That's just a good thing. Use PAM, no. And you're like, why would we not use PAM? Remember that thing about etc pam.d, the file, the text file that you can modify and in one line break all authentication? Don't use it. In practice, it's probably good. In a blue team competition, it's not really that good. So just set that to no. You can be a little more sneaky. You can change the port. That'll make it a lot harder for red team. Then we have to like search your box or scan your box and find out the new port and then go for that. You can do a custom config. So if we think we're modifying it, it's actually checking from somewhere else. But a lot of different things you can do. This over here, like it talks about SSH keys. Don't use them in competitions. Really don't recommend. And SSH keys in production and in the real world, absolutely, you should exclusively be using them. SSH keys in competitions, do not use them because here's the biggest problem with SSH keys. You cannot instantly just change it and have it redeployed across everything. So if I have SSH keys and I gave out 5 SSH keys for this box to the 5 different people on my team, and then I copy, as a red teamer, I'm going to copy your SSH key. Well, now you need to change it. How do you change it? You have to go and copy that key to 5 more places. That is a lot of time. That is a lot of work. Whereas with a password, you can literally just run one command and change the password. So don't use SSH keys in competitions, but use them everywhere else in life. Lastly, just check your logs. Again, I'm going to keep saying this. Just check your logs. In Debian-based systems in Ubuntu, the SSH logs to auth.log or sys.log, I think it's auth.log. It'll tell you every time someone logs in, every time someone's not allowed to log in, anytime someone uses the wrong password, anytime someone tries to log in and then Control-C's out of it. It will tell you everything SSH is doing at all times. So if you're like, I wonder if red team has access to my box, check this. It'll tell you. Hardening web. It's real common to get web shells around here, especially in blue team competitions. Quick and easy. Just disable all the PHP functions that can run commands. That's just a kind of a thing. Just lock them out. That's pretty easy to do. That'll break almost every single web shell, unless they start to get into like more crazy backdoors in the web server and everything. Again, check your logs. Back up your website. It can't hurt just to back it up, put it on a flash drive, put it in term bin, put it in paste bin. It doesn't matter. Just have some sort of backup. That way, if they delete it, if something happens, you can just reinstall your website and still keep scoring. It's not going to be uncommon to have backdoors in the services, especially like for web. I know our red team has one public on GitHub, so you can backdoor Nginx. So if you back up your website, you can just reinstall the web server, put the web code back, the website code back on there, and you're good as new right off the bat. So just backing up stuff is very important as well. Parsing log files. Okay, so here's where I say read the logs, read the logs, read the logs. here's where we kind of talk about what does that mean. The log files are going to be completely different, not completely different. There's similarities and there's like places where you should find your log files. There are going to be a little bit of differences though, where like one file might be named something on a different distribution. But primarily all of them, and I didn't actually put it in there, it's var log. So within var log, you should have all your log files. Use command line magic to look through these. If you're like, hey, I want everything for SSH, grep the log for SSH. You can show -A and -B, so it'll use grep, but then it'll show like 3 commands before, or 3 lines before and 3 lines after, give you a little context of like what happened before and after your log. You can do regular expressions. You can do that. If you're like, oh, I want to read this log file, but there's just too many cron notifications, then you can remove cron with -V. You can be like, show me everything except for that. So you just kind of use this to get a handle of what's going on, because there's a lot of information in these log files, and sometimes it can be overwhelming just to read through it all. You get head and tail. Tail's probably the most common one. Just like, show me the last 100 lines of a file, and then I'll go through there. And you can do -F to watch it. So if you have another shell pulled up, you can just watch your log. So as things are happening, it'll just be constantly updating. Like, oh, there, I see someone keep trying to log into my web server and it's failing, or I'm getting 404s or anything. Journal CTL, back to this. That log will tell you every single thing that's happening on your system as far as services go. Probably the most important log file. Absolutely check that out if you can. Okay, monitoring processes and services, just some quick command line magic. And you don't have to remember all this. I highly recommend practicing it though. Pull up a VM. We're going to have a Linux VM for the demo today. Throw these commands in there and see what happens, because I bet it'll help you find some flags. But practice some. Use this for reference. You can go back and look at all this. So PS, show everything, show the threads, full output, it'll show all that. That's like the processes that are running on the system. It's good to know if you see something that looks a little goofy. PS, FAUX, that'll show like a tree, so it'll show what spawned what. So it'll show you like, oh, SSH spawned this user, which spawned a bash shell, and then that bash shell is running these commands. That'll all be shown in there. Monitoring network connections. This is good, and it'll map the processes back. So if you're like, oh, I have a service listening on this port, it'll just show you what process ID, and then you can go back to PS and look at it. System CTL, list unit files. These will be like showing the services that are installed, not the processes, but the services that are running. It'll give you like a description of what they are, if they're running, if they're enabled, if they're started up, if they're not loaded at all, if they're erroring, all kinds of things will be in this. And you can look for things that look a little bit malicious, or even just things that you're like, that doesn't need to be running, so I'm going to kill it right now. Reconning the network, again, we have SS and netstat. So like, here's an example output of netstat. You can see like, in this case, this system is running 3 different services. It's running SSH, it's running Nginx for web, and it's running postfix on port 25. These commands, you can easily see from just this one command, you can see, okay, there's the process ID, there's the name of the process, and that's what it's listening on. So again, if you know I don't need to be running a mail server, then kill this service, kill that process ID. If you don't need to be running SSH on a local thing, kill SSH. It'll tell you what's listening. It's easy for Red Team to start up like simple bind shells, such as like open a port and listen, netcat shells. All of those will show in this output. So do that. TCP dump, this kind of tells you it's like Wireshark, but over the command line. So it's pretty useful if you're trying to debug something. You're like, hey, is this even hitting my web server? One of the most useful commands in a competition, TCP dump port 53, and then you'll see all the DNS traffic. So you're just like, hey, I wonder if they're beaconing to these URLs. It'll tell you, and you just watch the DNS, and it'll just show all the URLs it's hitting, and then you can go in and sinkhole them or delete them and find it based on that. So that's another useful command for monitoring the traffic that's going on. LSOF, this is a really cool thing. In Linux, there's always like the saying, everything is a file. Even if it's not a real file, it's mapped as a file 99% of the time. So like processes, mapped as a file. Network sockets, they're mapped as a file too. Actual files, well, they're still files. Everything's a file. So when you have a tool that's called list open files, it's really useful because you can list pretty much 99% of what the system is doing just with this one tool. You can look at process IDs. You can look at like protocols, for example, TCP or IPv4. You can do networking information, so you can look for any socket that's open on TCP, UDP, anything. There's a lot of really cool things you can do with LSOF, but it'll tell you what's going on in the system. So I would highly recommend looking into that tool as well. Okay, so now that's kind of like basic Linux defense, and there's a lot of talks. We give a talk on this about every semester, so like there's a lot of different things to look into, a lot of resources for this. We're going to talk now specifically about like blue teaming a competition. Like I'm on a team with 5 of my buddies. Let's try and kind of work together. So first thing, I have the competition loop is what I call it. It's like this should be your mindset at all times while you're in these competitions. So run your 5-minute plan. It'll lock down the basic, the easy things to do, your passwords, your users, and we'll talk about what a 5-minute plan is here in a little bit. But it'll like just run your 5-minute plan and do that. And then what you keep doing is you read your logs, you find an error or something, you find a login, you find something that went wrong, something that misconfigured, a service that was started that shouldn't have started, a process that died, a login, maybe Pam was just like, yeah, I'm accepting everyone. You find a user that shouldn't exist or doesn't exist, all kinds of fun things. Find your logs, track down the issue, and then try and fix the issue. And then you just keep looping that process. Every time you have free time, you should never just be sitting there. Just go read your log files until you find another thing. I promise you, there's going to be things in your log files that are wrong. So just go find them, because they will be there, absolutely. If you have more than one system to be on, go through the process once or twice, and then switch boxes. Oftentimes, red teams are going to be doing the same thing to like all the Linux boxes. So if you have 2 Linux boxes, find some problems, go to the next one. They're probably the same problems on that box too. So you can kind of reuse this across the thing. And just keep repeating this cycle of just, where's my problems? What's my system doing? All right, now I'm going to fix it, and now I'm going to go find another problem. You should never just be like sitting there being like, I don't know what to do. I've seen people in competitions like log into Facebook and like start scrolling through or like playing games. I'm like, what are you doing? They're like, oh, I looked through everything. I didn't find anything. I'm like, well, you didn't look hard enough, because I promise you there's like 40 beacons right now on your box. But so you should never have like free time. Just read the logs. There's plenty of reading material in there. It'll keep you going for quite a while. So just kind of keep doing this loop constantly. All right, what not to do. These are fun things. So we always, Owen?
So say I'm going through and I find something in my log, in competition. Should I document that somewhere? Or should I just...
Yeah, write it down. So that's a great point Owen's bringing up, talking about like documentation of what's going on. Some competitions focus more on it than others. I know like IRSec, the one we run in the spring, we focus heavily on like, what did you find? Write up a report. This is very much real world too. If you find something in the real world, again, I was talking about like users, don't just delete it. You want to be able to tell your boss, this is what I found. This is where it was. This is how I found it. Because again, it's probably going to be on other systems. Like in the real world, if you find a web shell, you probably want to start scanning all your other servers for the exact same web shell, because odds are you're going to find it across the network. So yeah, write down what you find. Don't just delete it. Keep track of it. And then again, you can go and use it, apply it to other systems. All right, what not to do. Don't just auto-kill users. That pisses off the red team a lot, mainly because you're not actually fixing problems. You're just like stopping them for about a second before they press up in their terminal and press enter to get another shell. So don't just like, a lot of times people just like watch netstat and they'll say, oh, I have an established connection. All right, kill the process. Oh, I have another established, kill the process. I'm just going to keep getting in there, and eventually I'm going to like delete kill or something so that you can't kill me anymore. It's not actually fixing anything. That is simply like slapping a Band-Aid on a stab wound. It's not doing anything. It's just maybe slowing it down a tiny, tiny bit. Don't auto-block IPs. Red team has, let's just say for the sake of fun, infinite IP addresses. So they're just going to get a new IP addresses. So you want to, instead of blacklisting IP addresses, you want to start whitelisting IP addresses. Instead of saying, everyone can access me except this one time that I saw a connection from here, instead say, no one can access me except for these good addresses, kind of thing. Again, these don't stop the red team. There's always ways around this. Don't delete all the malware you find. We just talked about this. And don't just start murdering processes. It's oftentimes overwhelming. If you type in ps-e, you see a ton of different things, and you're just like, oh, some of these look really weird. There's this one thing called rtkit on Linux, and a lot of blue teams are like, oh, rtkit, rootkit, must be bad. That's actually kind of a valid Linux thing. I think it's like real-time kit or something. But like, people start deleting things on the system, and it can be actual important things that your system needs to run, and you can have unintended consequences if you don't know what you're deleting. One time we put one of our good Linux guys on a Windows box, and he was looking and he saw like a bunch of LSAS processes, and he's like, these things keep spawning up. So he just killed all the LSAS processes. Well, LSAS is like a really, really core critical component of Windows, and it will break a ton of things. It'll just blue screen if you kill them all, I think. So don't just start murdering processes without knowing what they're doing. Really kind of look into it more. So like once you have these processes, go back and use your tools that you have available. Look at LSOF, look at netstat to try and see, is this making network activity? Is this process listening on anything? Is this process reaching out? And then kind of trace it and then determine whether or not it's good or bad. You can use Google. If it's a legitimate Linux process, it will be on Google. So start Googling things like, hey, what is RTKit? And then is it bad? Can I kill it? That kind of stuff before you do it. All right, common reasons services are down. This is a big thing on blue team. Things are going to break a lot. And knowing that you have a red team there attacking you makes it really easy for the blue team to be like, oh, red team did this to me. 99% of the time, unless it's like the last hour, we didn't. You probably did it to yourself. You turned your service off, or maybe we turned your service off, but that's still an easy one to fix. Start it back up again, right? People are like, oh, my website's down. Like, did you turn it on? It's blocked by the firewalls. I promise you, red team is not writing firewall rules to block things. We love not having firewalls. So if there's a firewall issue, you did it to yourself. Check your firewalls, see what's going on in there. And we're not talking about firewalls in this talk. It's a lot. Like you could have entire presentations just on firewalls, which we do. You can check our YouTube. Go check those out. But again, it's another important process, but we'll just kind of go from there. You misconfigured it. It's really easy, again, to make a typo in your configuration file. And you're like, oh, man, I'm starting my service. I typed in service nginx start, and nothing happened, or it errored. You're like, what's going on? I did it right. You probably didn't do it right. And it will tell you exactly what you did wrong in the log file. It'll be like, oh, nginx couldn't start because you forgot a semicolon at the end of your listens block. And it's like, darn it. That happens a lot. Know what good configs look like, too. Get familiar with the services you're looking at. There's not that many services that you're going to really see. There's like a couple web servers, a couple mail servers, GitLab, SSH. It's not like overall you'll see a pattern where it's the same services over and over again. You usually kind of get familiar with them as you do it. If you've taken net services or sysadmin, basically the stuff you do in there is probably, if you get familiar with those configs and like do those labs, you'll have a good understanding of what you're going to see. If you still don't know, you can do service status. That'll tell you the status of a service. It'll tell you why it wouldn't start. The logs, again, they're going to tell you. If it's not in the logs, then something is seriously messed up because it's 99. I've actually never not seen something in the logs. And then, yeah, journal CTL, that's going to do it. So there's a lot of reasons things can break. The logs will tell you how it's not broken. And if it's not in the log file, it's your IP tables rules. OK. What to watch for? Again, you have a lot of different things going on the system. There's a massive attack surface. Just kind of keep going through these as you go through. This kind of here's a reference. There's another really good grid here. There's a variety of persistence you might face. So backdoored service files, web shells, backdooring the actual binaries themselves, default credentials like rootkits sometimes, that depending on the red team, modified master boot record. If you have that problem, it's pretty much game over. Just enjoy playing Floppy Bird. Malicious cron jobs, alias commands, again, all these things that are just going to be running code on your system, just kind of an attack surface. But again, most of this you can find through like watching the network, watching your established connections, checking the files, putting up good firewall rules, and like going through the processes that we just talked about. So this is kind of here's a reference, like things I need to be thinking about. All right, so we talked about the 5-minute plan. The 5-minute plan is a pretty basic concept, and it's going to be write down what you're going to do for the first 5 minutes when you get on a box. Because you're like, oh, I've done this 1,000 times. You probably have done it 1,000 times. You probably haven't, but even if you've done it a bunch, you're going to forget. You're going to sit down in this competition. There's going to be so many people around you. Everything's going to start breaking suddenly. You're going to forget things. You're going to be like, oh, I don't remember what that one command was, or what's that flag to do this? Write it down. Put it on a piece of paper right in front of you and just says, run this command, run this command, run this command, run this command. Those commands are going to be the things we just talked about. Default passwords, change password, firewall rules. It'll be like, here's the literal IP tables command to write out. Press enter. Next one. Reading the logs. Put a nice grep in there, a nice like cat, grep it for SSH, grep it for PAM, those kind of things. The 5-minute plan does not consist of really complex problems, like if you're going to spend more than 4 minutes on a problem, don't put it in your 5-minute plan. You wait till like the past 10 minutes to do kind of this. This is just for the quick things, the things that are going to have really high impact and are really easy to do. So put all this stuff later. You can document that, but that comes a little bit later in the game because you can have a really, really nice logging server, but if you haven't changed your password, it doesn't matter. So again, here's like just kind of an example of what goes in there. Change your password, disable accounts, limit sudo, SSH, firewall rules, reinstall binaries. Just put the commands for all this in there so you can just go down as you go right in the very beginning. Again, high impact, low effort. It's one line to change your password, but that can stop red team in their tracks if they haven't done anything yet. Again, so just kind of go back and take all these commands and just stack them in there, practice it out. So yeah, any questions? Any thoughts? Okay, who here is blue teaming or will be blue teaming this semester? In class or in a competition? Yeah? All right, so maybe you'll learn something from this. There's a lot of people here who've done it. There's a lot of people on red team as well, so we like to talk about red team, so ask us how we break things and we'll tell you, and then you know how to fix them.
Should I kill all of red team shells all the time?
No. Well, you should, but don't. We'll get mad. All right, so there is there's a challenge. If you're not familiar or you haven't done this before, go to this thing and you can download a little bit, it's like a 1 gig VM we have set up, a Linux VM. Run it in VM